Hello, welcome everyone to Math in the School Garden. My name is Dinah Mack. I am the Education Program Manager with Mass Farm to School. And I am here with Elizabeth Kaplan, who is the K to 8 Math and Science Coordinator with Watertown Public Schools. And so I'm going to be giving the floor over to Elizabeth, who is going to share her ideas and expertise on how to teach the maths in the
The
school
math.
garden. The maths. And welcome
So
everyone.
so
And
so
the chat
British,
and the
so
chat
British
is
of you.
open.
Great. Thank you. Hi everyone. I'm just going to pull up the chat so I can see who's commenting. I'm Elizabeth. As Dinah said, I'm the math and science coordinator in grades K through 8 in Watertown Public Schools, and I'm also the farm to school coordinator in our district. And we have loved our partnership that we've had for many years with Mass Farm to School. And I'm happy to talk to you about math in the school garden today. So there will be some participation that I'll ask you to do in the chat. Feel free to raise your hand. I will be monitoring that, so I will pause and answer any questions you may have, whether you want to ask them, you will ask them through the chat. I would love to answer them, but we'll also have time at the end. So here we go. Any pictures you see are from Watertown Public Schools Farm to School program. So that's a picture of our Hosmer Learning Garden. So today, our objectives for today are to really designed to hopefully equip you with practical strategies for integrating math instruction into your school garden. I hope you will leave with some strategies and ideas that you can implement immediately, kind of along with a deeper understanding of how garden-based learning supports math. My iMessage is not turning off. Sorry about that. The other piece that we're going to talk about briefly, that's kind of the elephant in the room when we talk about math and integrating the garden, is the challenges that come along with it. There are challenges. There's a lot of math that needs to be taught during the school year, and we in Watertown have had a hard time into taking time out of math class for it, but we've made some things work, and I hope to share that with you today. So we're going to talk about connecting the math standards. Anytime I'm talking about curriculum and school garden connections or farm to school and curriculum connections, I'm a broken record. I always talk about how it's important to link to the standards. And we have, amazing standards in Massachusetts that are easily linked to our school gardens. We're going to explore activities by grade level. I have K to 5 written here. We do have extensions up through 8th grade as well. So if we have some middle school folks here, we will be talking about that as well. And then giving you some ideas on how to create meaningful tasks. And I hope that you leave with some ready to use resources today. So thank you, everybody. So the first thing I would love to know, just who has done what here. This is a Menti, so if you can you can't click on the link, but I could probably put it in the chat. If you could use your phone for the QR code and just answer a prompt that I have. I'm wondering what kind of curriculum connections you have made or experiences in your school garden. So I'm going to open up that for you. And hopefully we'll be able to see your responses. I'm going to put the link in the chat as well. So if you don't want to use the QR code, here's the link. We have one participant. Hopefully we'll have some more. Great. I'm going to give it a couple more minutes. Okay. Give it another minute. Okay, so I'm going to stop there. I think we have a few more participants joining us. Um, what kind of curriculum connections have you made? This is what I expected to see. So I didn't do this on purpose, but I did expect to see that the lowest results would be in math. Math can be the hardest to integrate with for many reasons that I sort of just mentioned. But it's great to see we have connections being made in literacy, science, social studies, as well as health and wellness and art and music. Literacy and science are two areas, and social studies are three areas in Watertown where we have some really strong connections as well. But it can be done in math, and that's what we're here to talk about today. So thank you for participating in that. So why math in the garden? And again, here's a picture of our students planting in one of our gardens. So it's when we're teaching math, and I'm going to put my math coordinator hat on right now, and I don't know who's in the room. I probably should have asked in our webinar, but when we're teaching math, particularly in K to 5, it's really important to make math concrete. So we follow a concrete pictorial abstract approach. So concrete is when my iMessages, I'm turning them off. So concrete is when we are actually using manipulatives or concrete materials. Pictorial is when we're using images, and abstract is that standard algorithm that we all learned when we taught math or when we learned math. It's long division, it's all of that. And so to really get at the concrete, the garden does that for us. It makes abstract concepts concrete and meaningful for students. It provides a real world context, which is really important to do in math. And and it's really supportive of multilingual learners and hands-on learners as well. So it's really aligned with best practices in math teaching, which is concretely introducing concepts to students. So if you have questions as you go, you can put them in the chat and Dinah's monitoring it. I said that before. I'm saying it again. So math domains that grow in the garden part. There's a lot of math and garden puns on here today, so I just will be upfront about that. Measurement and data. So these domains are kind of larger domains within our Massachusetts science standards. So we have measurement and data, numbers and operations, algebraic thinking, which fractions falls under that, geometry. The most important work of math in elementary school is numbers and operations and algebraic thinking. That said, measurement and data is important as well, and often less time is spent on measurement and data and geometry in grades K through 5. And for that reason, the connections to the garden for these lesser important or time is spent less on measurement and data and geometry. These are great places to tie to the garden because, there's a little bit less at stake with in the less amount of time spent in math. So in terms of measurement and data, there's a ton to do, and we're going to dig into it by grade level, measuring plant growth, tracking weather, analyzing patterns over time. Again, you can collect and organize and interpret data from plant growth, weather, harvest yields. I will show you some examples of how we've used graphing and data in in Watertown as well. For numbers and operations, counting seeds, comparing quantities, and building multiplication foundations through garden rows is really applicable, particularly in third grade when we're learning to multiply. Geometry, shape, symmetry, spatial reasoning through garden bed layouts and plant patterns. And last but not least, fractions. Once you get to third grade and on up, fractions are extremely important, but also really, really challenging. And for that reason, making those concrete is something that teachers always strive to do. We have a lot of these fraction manipulatives, but it's really easy to do in a garden. So I'm not sure if people here are familiar with the standards, and I'm not going to pull up the DESI document with the standards because that's not fun and it is important, but it is not something that we are necessarily here to do today. But the standards exist as content standards for math by grade level. But K through 12, there are what we call the standards of mathematical practices. And they exist for science, they exist for social studies. They're practices that students should engage in throughout the year, throughout their school career, that helps them make sense of the content. So there are 8 mathematical practices, but the three that really stand out for linking to the garden are making sense of problems and persevering. That's the second part. Using tools strategically. So those tools could be measurement tools, those tools could be manipulatives, and attending to precision. So those are mathematical practices that we really want our students engaging in all throughout their unit, but the garden really, really makes these three easy. So, any questions before we dig into grade level? I've lost my chat here.
Well, we have a comment, Elizabeth.
Yes, I'm opening.
Um, Very exciting stuff. I'm thinking about one of our school's fifth grade teachers. Today, she had her students harvesting lettuce from a grow tower and writing down the weight of each head of lettuce in fractions.
That's amazing. We're going to talk about our grow tower and fractions today too. So that's wonderful. That's great. In fifth grade, they are heavy in fractions right now in fifth grade. So in grades K through 1, really the early math skills, counting and cardinality, one-to-one correspondence, our students are able to count. Sorting and classifying is a science standard and it's a math standards in kindergarten. And then there's math standards around non-standard measurement. So we have our students comparing using words bigger than, smaller than in kindergarten. And so for counting and comparing, you'll see the picture here. That's a 10 frame. A 10 frame is used K1, 2 in math, and it's an excellent pictorial tool. Using 10 frames with beans from our gardens is something that we do. We actually had one of our math coaches in the garden spray painting our dried beans 2 different colors out in the garden because we needed counters and we needed two-sided counters. So we used beans for that. But using a 10 frame and using the beans for that is it's an easy manipulative. In terms of sorting and classifying, again, I have beans here. I'm teaching a PD session in person on beans in the month of May, so I have a lot of bean content. It's not going to be only about beans today. Is that sorting and classifying beans or seeds is an excellent activity. We find beans easier for kindergarten because they're easier to grasp than seeds with fine motor. Non-standard measurement, and I'm going through each grade level quickly here, but then at the end I have links to lessons actually for each of these kind of concepts. Non-standard measurement, you can compare plant sizes, bigger than, smaller than. Same thing here, we're comparing the sizes of beans. Very easy. These things can be done, everything we're talking about, some of the things we're talking about may be done on pencil and paper in the classroom. So it does not have to be I'm overwhelmed. I can't get my class out to the garden, but I want to integrate the gardens. This can be done in the classroom, whether you're bringing things in or you're using images from your garden. They've been out into the garden for literacy, but now you're working in math during your math block and you're in the classroom. It doesn't have to mean you take your class out to the garden every time you're doing these activities. So we're doing math breaks 3 times today. So for our math break, you guys may be at the end of your workday and tired and you're thinking, I don't want to do math, but I promise it's low stakes math. So for this math break, we're acting as students, and I don't know if anybody's familiar with a which one doesn't belong. But what we have here is we have 4 images, and it might be numbers, it could be anything. A, B, C, and D. And I'm asking you to take a minute to think which one doesn't belong. And there's the thing with which one doesn't belong is there is no right answer. So this is a low floor, high ceiling activity that every student can access, which is, one of the characteristics of a good math task. So in the chat, you can take a minute to think which one doesn't belong. Make your opinion known. Say A because. So you're going to tell us which one doesn't belong and why.
Elizabeth, I'm glad you said there's no wrong answer because I started to panic.
Yeah,
And so you basically, students just need to justify
exactly. So
their
you are
thinking.
making a choice and you're justifying your thinking. And which one doesn't belong is a routine that is in many curriculum for math and it becomes students really understand quickly. There's no right or wrong answer. And it doesn't, I will tell you this, it doesn't have to be a math answer either. Ideally, we'd love it to be, but it doesn't have to be. And often students do not come up with math answers. So we'll see what everybody comes up with here.
Okay. Emily said A, C, and D are all multiples of six, but B has more than six.
Yeah.
And Anna said, I think either B doesn't belong because it's a picture of flowers, not an edible fruit and
Yeah.
veggie.
We have the tulips.
Hope
B.
said the tulips because they're not veggies.
Yep.
Okay.
Does anybody have anything else outside of these two?
Hmm.
Could be anything.
Or maybe A doesn't belong because it's not cold tolerant.
Ooh, not cold tolerant. That's great. I've had somebody say, you know, C because they're not growing in bunches. They're individual carrots. They appear to be individual carrots. We had a student say that. And we had to kind of say, well, the tulips look like they're in bunches, and you might buy tulips in a bunch, but they're actually growing individual flowers. So this is a way to integrate math into your which one doesn't belong routine. We had A, C, and D are all multiples of six, but B has more than six. That might be highlighted, and we might use that as a launch pad to go into some talk about multiplication. Carrots also grow mostly underground. Yeah, that's great. So nice job. So this is an example of, a which one doesn't belong. This would take you 2 minutes to make and substitute to integrate your school gardens into a normal math routine that you may have.
Hmm.
So great job on that, everybody. So in grades 2 through 3, we're still, there is still students are learning in grade 2 to add and subtract multi-digit numbers. At the end of the year, they're really learning the foundations of multiplication. For the future, there is a bit of measurement. There's coins and math involved in the second grade standards, but really, second grade is a heavy, heavy year for multi-digit subtraction and addition. And oftentimes students are learning many, many different strategies for that. Some of the strategies wreck parents' heads, to be honest with you, because they're really ways that we didn't learn, but we're always teaching concrete, pictorially, and abstract. So, a way to integrate the gardens is really around that concrete way of bringing in pieces of the garden. So for measurement and tracking, we talked about measuring plants. That's an obvious one, and graphing. What we have here is this could be done with any grade level. This was put out not by a teacher, but our garden coordinator. So it's done sometimes a couple times a year. Students are in the garden, and again, it's not during math class necessarily. They're voting for their favorite flower that we have. They're voting for their favorite garden snack, and they're voting for, what to grow next year. Then our garden coordinator might ask a couple of classes when they're within their data and their graphing unit, say, hey, I have this data from the school. Do you guys want to do something with it? And then they're integrating it into their math lesson. So again, this theme is you aren't taking, as a math coordinator, I'd say my favorite part of my job is my farm to school coordinating, but a large part of my job is my math coordinator job. And I have to make sure that students receive all that content and all those standards by the end of the year for math. And sometimes we are on teachers to stay on pace. So these examples I'm giving you are not examples of take 3 days off of your math curriculum and go do this. These are lessons that can be subbed in when you're learning that content, which is, I think, the big message that I want people to hear. Arrays and multiplication. We just did that which one doesn't belong, where we were kind of talking about kind of looking at an array, which is an arrangement of rows and columns of an object. You can see here, and I don't want to give away our next math break, but you could do a multiplication problem with that picture of those graphing activities as well. You can have students forming arrays with rocks as well. So it could just be an outdoor learning situation. So grades 2 and 3, you're really into multi-digit stuff, graphing a little bit more complex with more data. So we give them a lot of data from our garden to work with. And again, starting to really think about multiplication. So we're doing math again. This is a picture of, does anybody want to guess what leaves those are? I bet everybody can. We're all farm to school people here. We've got some parsley leaves, I think, parsley. Um, Write a very brief math story problem, or it could just be a math problem about this image, and we'd like you to solve it. So remember, we're in third grade, we're multiplying. If people want to write a math story problem about this image and solve it, and you can take your time on this.
I like this. You're keeping us on our toes with
Yeah, I
mathematical
try to
thinking.
make a webinar interactive, but
I like it. And welcome to people who are just arriving. And don't panic if you're if math stresses you out.
and again,
All right,
if math stresses you out, it's okay. It's no wrong answer.
we got one so far. You have four parsley sprigs. There are three leaves
Emily,
on each sprig. How many total leaves do you have?
that's great. Is there's another
Emily took mine.
that's yeah, that's pretty much what people come up with. There is another way you could um maybe you're not maybe you write it more. This is Emily wrote it in a way that's multiplication. So her problem would be 4 times 3 equals 12. Somebody else might represent it as repeated addition. So we could say, oh, it's 3 plus 3 plus 3 plus 3. So some students may be at that place where they can look at this and they can make a multiplication problem, but some students may still be in the repeated addition part of multiplication. So seeing it as repeated addition, not there with the fact yet. So this is, you could do this along the spectrum of repeated addition on up to multiplication. You could also just if you're in the garden and you are, I'm not sure if this is third grade, but arrange the leaves from biggest to smallest, estimate how much bigger the highest leaf is the smallest. Absolutely. You could do that too.
You could also think about multiplying something times one, right? There's
Yeah.
one. If you separate these, there aren't four.
Yep.
You could look at each one individually.
Exactly. Yep. Exactly. Yep. Emily has a
Arrange the
fourth
leaves from
grader.
biggest to smallest.
Emily knows how to write some math story problems. So there we go. Oh, here's a good one. Anna, kitchen manager is making chicken parm as a special senior meal for lunch in May. For each tray of 20, the manager needs one bunch of parsley. How many bunches will the manager need to order from Fruit Fair Market in order to serve 300 lunches? That is great, and it involves parsley. That's wonderful. Thank you. So again, this might be an image from your garden. You might be outside in the garden in for another reason and not in math class, and you can take a math break and say, "Oh, let's do some math really quickly." It does not have to be taking a total math class out of your week to do this. All right, grades 4 and 5. There's so much you can do in grades 4 and 5. So again, students are really ramping up and they are ideally fluent in their math facts by now. In a perfect world, everybody would be fluent in their math facts by then. It's just not the case. Students learn differently. But really working on fractions in fourth and fifth grade. Geometry gets much more complex for fourth and fifth graders. We have angles, area, and perimeter. Um, you start in fifth grade to talk about volume. The first unit of sixth grade typically is surface area. So geometry starts to become more important in these upper grades, and there's a ton of geometry to do in the garden. So I have data analysis here. You can just be giving students more complex data sets to work with as they get older, and there's a ton of data sets you can do. In terms of area and perimeter, this is a picture of one of our students in one of our old beds. We have new beds now. I miss our old beds. Measuring and actually doing area and perimeter of our existing garden beds. And that was during math class. That was instead of working on a worksheet that had a written problem, they went outside and did that. In terms of fractions, you can see here, this is a bed where students were kind of planning things out, and there was a whole bunch of math fraction problems associated with that. And I do have a link to actually garden-based fraction problems as well. So in fourth and fifth grade, another thing that I'm going to talk about, but I have links to is garden planning. So in our district, we have this is like another session, but we have on our curriculum map almost a strand for the garden themes for the year. And so, set first grades is how can gardens help the community? Our first graders end up harvesting some things they planted in kindergarten and donating it to our community fridge. So that's the kind of thing that gets with that. Fifth grade's theme is how can you build an excellent functioning garden. And with that comes garden planning. And with that comes a ton of math. That's kind of a cumulative project for fifth grade. Now, we sometimes do it during math time at the end of the year, or we will do it during science after science MCAS. They kind of plan, and the garden plans then go to our garden coordinator to help inform them. All right, so we're going to do one last math break here. So this is I'm gonna hype and give a shout out to a bunch of things here with this image. This is an image of one of our walls in our freight farm in Watertown. So we have this is our first year of growing about 1,000 heads of lettuce a week. It's a high school high-tech farming class. There's a ton of math involved with that freight farm. But this is a picture of the wall. We actually have brought pieces of the wall to the elementary schools and shown them, just kind of really expose them to what's happening at the high school, get them excited about it, but also do some math with some of these panels. So this is a hydroponic lettuce wall is divided into 4 equal sections. Now, people who are stressed out about math, you don't have to solve this. This is like a straight up math problem. Um, a fourth of the wall has green lettuce. A fourth of the wall has red lettuce. The rest of the wall has romaine. Um, this problem is inaccurate. We're growing many more varieties in this wall, but you get the picture. So 3 questions. What fraction of the wall is filled with romaine lettuce? If there are 40 total heads of lettuce, how many are romaine? And how many heads of lettuce are green and red combined? So this is, you can opt out of this if you don't feel like doing math. But I'll give you some time. And I solved it right before we came here, so I've got the answers.
Elizabeth Kaplan. What do you mean,
Yeah.
how many heads of lettuce are green and red combined? It's like a hybrid red-green lettuce?
Nope. So we have a quarter. Great. Thank you for asking that clarifying question. So a quarter of the wall is green and a quarter has red. So how much lettuce, how many heads are red and green combined?
Got it. Okay. Okay.
Great question.
I'm the person that you'd be like, creative thinker.
I like your thinking. I went from really open-ended math to like, let's do work with fractions. I apologize, everybody. All right. I'm gonna highlight Emily. No, Emily, you're correct. So we have 3 different, I think I think it's misleading. So we have 3 different varieties here. Let's say we have a green bib is what it should have said. We have a red lettuce and then we have a romaine. So because we see green and red, 50% of the wall is green and red lettuce. 50% would be romaine. I'm not considering romaine a green lettuce here. I see what people are doing. If there are 40 heads total and we know 50% of them are romaine, that means 20 heads are romaine. And then it means 20 heads of lettuce are green and red. So Emily, your first answer was correct, but then I see people are saying they're all green and red. The romaine is confusing me. So we're not counting romaine in with the green. It's a separate variety. So you caught me on that one. I'm sure a student would too. So they could actually be looking at a panel and you could be doing this and it's in the classroom and it just livens things up. Our lettuce also looks fake, students say, so they really enjoy looking at it and touching it when we bring a panel in. Nice work, everybody. That was great. So that's kind of a very quick tour through K to 5. And again, some of the fifth grade could be, all of this could be scaled up for upper grades. What you want to think, what makes this a strong math task? Because you don't want to waste students' time and time is precious. Strong math tasks engage students at multiple levels and promote deeper thinking. Even though which one doesn't belong is considered a wrong, as it's considered a strong math task because everybody has an entry point, right? So you can go as far as you want with that. You could talk about the mass of the tomatoes versus the tulips versus the carrots versus the lettuce. You could just say, oh, you know, three of them have colors and the other ones just have rainbow colors, the other one's green. I don't, you could say anything. So you can engage students on multiple levels. Garden-based tasks naturally incorporate modeling and reasoning. And so modeling with math is really important. Once you do get to high school, there's not a whole lot of modeling, not in many high school math classes. So it's really important to take the opportunity when students are in K to 8. I'm the middle school math coordinator. I encourage our teachers to be modeling with our students all the time. And again, it's authentic problems. So we all know that anytime learning is authentic, connected to students' worlds, it's going to be more meaningful. So again, multiple entry points for diverse learners. You want to encourage discussion and justification of reasoning. So we almost could have had a discussion right there about, okay, romaine lettuce is technically green. What does this mean? Let's solve this problem in two ways. And then easily scaffolded or extended for differentiation. Differentiation is important in schools. It's really important in math. If you've taught a class of 20 learners, they are all on a very wide spectrum of their math abilities. We have students who are involved in Russian math outside of school whose parents say they're doing calculus in fourth grade. We have students who may be new to our country and learned math differently where they are from and in a different place. And so scaffolding and differentiation is so important in math, and working with models and hands-on things is a way to do that. So if you are going to be planning, I've ripped through this, but maybe we can have questions at the end and I'll show you the resources. If you're going to be planning for your classroom, or if you're a garden coordinator and you want a teacher doing this, or if you are in my role and you want teachers doing this, the big challenges are right here. It's time, it's collaboration partners, depending on what role you're in, and it's coverage of standards. So I'll just say a long time ago when I was a principal and then I became a math science coordinator, and our superintendent at the time wanted to have a STEAM team, really wanted to have STEAM. So science, technology, engineering, arts, and math. And I felt like some people thought I was anti-STEAM, which I'm not. I'm not anti-STEAM or STEM, but I felt like at the time we didn't have the M down. We didn't have the math. We weren't teaching all the students all the standards for math a year. And then they were going to the next grade and having skill gaps. And those teachers were like, I can't teach this because our students didn't learn that. So really need to have a high quality tier one math curriculum in place where students have the opportunity to learn all the standards that Massachusetts sets forth by the end of that grade. Because of that, time is a challenge, and time's a challenge in schools no matter what, but I find time to be more of a challenge with math. So for that reason, and I've said this a couple times, it's important to find ways to integrate these authentic, connected experiences without taking days off of your math lesson, your math curriculum. And it can be done. You can sub your which one doesn't belong. You can rewrite a couple of problems. It makes the learning more meaningful that way. Or you're making the math connections when you're out in the garden during science time, or when you are out in the garden with your garden coordinator. The collaboration partner is a challenge as well, because you want to say you're working with your garden coordinator, or you're a garden coordinator looking to work with a teacher. You want to have everybody on the same page with making meaningful math garden tasks. So ideally you have somebody to work with and you're not trying to do this on your own. It can be done on your own if you're a classroom teacher, but it can be hard. You want to partner with your garden coordinator or your garden teacher leader or your school nutrition director if they have dried beans available for you. So finding a collaboration partner to do this is important. And then last but not least, I keep talking about it, you have to cover the standards by the end of the year. So not spending a ton of time on one thing, but moving through what you need to move through while having these little experiences or strategic or doing a bigger project like I talked about the square foot gardening planning project, but strategically placing that at a time of year where students are able to do the work, the math work, and you have the time. So in terms of making the connections, thinking about I'm over here now, which upcoming math unit fits naturally in the garden setting and has time and space for integration. So I'd say everything, as you saw here, every unit has connections to the garden, but thinking about where is there going to be a best fit? Or is there a part in the math curriculum that's kind of boring and they're graphing kind of really boring data and let's give them some garden data to graph. Or those fraction word problems are really boring and have the students' names are really lame. Rewrite them with your students' names, rewrite them with diverse names and bring in some garden scenarios to those problems. First lesson idea, asking you to think about what is one lesson you could try this month in the garden. So I'm going to show you some resources in a minute and to think about that. And then obviously materials needed. What materials will students need? We didn't have meter sticks for a we didn't have meter sticks for classrooms a few years ago. And I was like, we need meter sticks. We need them in the garden. We need them in classrooms. There's so many opportunities to break out your meter sticks and measure your garden beds or measure some plants. Having a lot of measurement tools is something that's a one-time buy and really important for integrating math into the garden. Various types of graph paper, depending on how old your students are. That's another, you can print that. But that's another important piece to have to do these math integrations. Getting dried beans, getting dried seeds from your garden, those are free and those are really easy ways to make those connections. Check the chat. Check the chat. Love this example. Thank you. So before I show you what we have here, I want to highlight this book. So I don't know, does anybody have this book? I have this book. I was telling Dinah about it before. Math in the Garden, Hands-on Activities that Bring Math to Life. It looks like an old book. I think it is. It is, yep, Emily loves this book. Yes, we love this book. It is like the anchor text for Math in the Garden. There's a ton of lessons. It's a book, it's not a website, and it's just a wonderful thing to have on your shelf. I go back to it often in my role. There's also like an online course. I think it has a cost to it, a companion course with this book. Just I recommend getting this book if you have the budget for it and just having it. It's not cheap either because I think it's old, but it's a wonderful anchor text for all of this. I did not pull out when I didn't pull out too many examples from this because I wanted to keep this as kind of a fresh surprise. So start small, start with one standard, one activity, or one problem. Focus on math thinking, not just the activity. So everything we did today was grounded in a certain kind of math thinking or math practice. So it can be easy to just be like, oh, we're going to rewrite this problem to have garden things in it. The things we did today actually have some deeper math thinking involved with them. So thinking about that versus I'm just going to get some beans out or have them measure. Think about what the thinking is behind it. Building routines for measuring and data collection, that is a really easy way to integrate math for the whole year. So, okay, in the fall, we're going to vote on, our favorite snack from the garden, or in the winter, like throughout the year, you can have different data points where you're graphing things to do with the garden. So building routines for that. Building routines. Oftentimes in science, we have a garden journal. You can do the same thing. If you have a garden journal, you can integrate some math and data into that as well. And then we always say, and I know Mass Farm School, revisiting the same space across seasons. So not forgetting about your garden in the winter because there's math that can be done there as well. Um, I have here there's a link here that I'm going to put in the chat that links to this folder. It's not a folder. It's actually just a document. So you can get into a rabbit hole on the internet. Did you guys know that? I'm sure everybody knows that. And there's a lot out there. there's a lot of bad stuff out there too. So what I have here is some highlights of my favorite things. There are links to curricula like the Teachers College Garden Food curricula, which has been shared through Mass Farm to School many times. And I've taken a Root Ed course where they've shared this. And then there's ag math lessons as well. But these are actually individual lessons that tie into what we were sort of talking about. So I'm going to put those in the chat here. Oh, it's $35. That's not that expensive, but it's not that cheap. It's worth the $35 a book. Thank you, Dinah. Okay. So these are resources. I would love questions or comments or anything. I have my email up here. That's our Watertown Harvest logo, but where that's the name of our group that grows the lettuce. So I always put our logo and everything. And then I have Mass Farm to School on here because they are hosting this and so supportive of all of our work in Watertown, and I'm sure many of your work as well. So for 411, I would love to take questions or comments or anything, or don't need to. And Dinah, will you send the slides to people after this? Is that the
Yes, I was just putting together an email to Dina
awesome?
that includes the links for the book and
Oh, to
this
Dina.
great
Perfect.
document sheet. So
Thank
she will
you.
send out the slides as
Awesome.
well as this great document and the book link as well.
Awesome. Thank you. Anybody have any questions? I'm here. If not, you can say goodbye and go and onto your day. But I hope you pulled away some examples and some had some fun doing some math today.
All right. Any questions before we let Elizabeth leave her school building and you all go out free? All right. Well, Elizabeth, thank you so much.
Thank you, everybody.
Emily wrote the math breaks
Oh,
intimidated me at first, but were really fun. I could see incorporating those into garden time.
I hope.
Thanks,
Thank you,
Elizabeth. So great to
Emily.
see you. I'm still thinking about the lettuce, Yes,
That's problems getting rewritten today.
I'm thinking about that lettuce
Yep.
problem.
Yep.
And I think it's really interesting. If I had learned math this way, I maybe would be, with the Artemis crew right now.
I
Who
know.
knows?
Well, what we say is there's no such thing as not being a math person. So everybody's a math person. So
Great. So
yeah,
thank you so much, everyone, for coming. And we will send all these things to you and enjoy this spring weather.
it's beautiful.
Finally. And thank you, Elizabeth, again.
Thank you. All right.